Hello everyone, welcome to Himachal Pradesh University e-learning platform. My name is Rohit Kumar Verma. I am working as assistant professor in Department of Computer Science, Himachal Pradesh University, Regional Center Dharamshala. Today in our session we are covering a very important topic of data structure and which is related to queue. What is an queue? So dear students, a queue is a linear data structure which follow FIFO principle. Now what is FIFO? First in, first out. Okay, so what you have to remember, a queue is a linear data structure which follow first in, first out principle. Second thing you have to remember, in case of queue, dear students, we have two pointer. Okay, our first pointer is for front and our second pointer is for rear, or we can say that in case of queue we have two ends. One end is known as front and second end is known as rear. Okay, so I think there is a question in your mind, sir, what is front end and what is rear end? So dear students, whenever you are performing insert operation in a queue. Which operation? Insert operation in a queue. That operation is performed at one end and that end is known as rear end. Okay, and whenever you are performing delete operation, so that delete operation is performed at another end and that end is known as front end. Okay, so today we learn two things. The end which is used for insert operation in case of queue is known as rear end, and the end which is used to delete operation in case of queue is known as front end. Okay, I think these two concepts are clear now. So dear students, as you can see in this image we have a queue. Okay, second thing you can see here, with insertion I can write NQ and with deletion I can write DQ. Now why I am writing NQ and DQ? So dear students, technically whenever you are inserting an item into the queue, whenever you are inserting an item into the queue, it is known as NQ. What is? It is known as NQ operation. So remember that whenever we have to add an item to the queue, we are using NQ operation. Second thing, dear students, whenever we have to remove an item from the queue, we are using DQ operation. Okay, so whenever we want to delete an item from the queue, we are using DQ operation. So here in this image you can see at insertion side we have our rear end and at deletion side we have our front end. Now dear students, we are learning few more functions that are used in queue operation. Okay, now our first function is peak function. So what is an peak function? So dear students, whenever you want to get the element at the front of the queue without removing it, okay, whenever you want to get the element at the front of the queue without removing it, you are using peak operation. Okay, dear students, we have another function that is full function. Why we are using full function? To check whether the queue is full or not. Okay, so if we want to check whether the queue is full or not, we are using is full function. Similarly, dear students, we have another function, that is empty function. So why we are using is empty function? So whenever we want to check if the queue is empty, then we are using is empty function. So dear students, right now we are learning 4 basic operations of a queue. The first operation is NQ, which is used to add an item into the queue. Second one is DQ, to remove an item from the queue. Third operation is peek operation, which is used to get the element at the front of the queue without removing it. Our fourth operation is full operation, which is used to check if the queue is full or not. Our fifth operation is empty operation, which is used to check if the queue is empty or not. Okay, so this is our brief description regarding queue and its operation. Now dear students, here we can see an algorithm for insertion operation. So what happened, dear students, always remember the rear end is used for insertion and the front end is used for deletion. So dear students, in case of queue, we have always two type of condition. Our first condition is when the queue is overflow, and second condition is when the queue is underflow. So always remember, in case of insertion, whenever you are finding a condition when the rear is equal to maximum minus 1, this means that when your rear will point the last location of queue, okay, that is full. And if you want to insert an item but you are not able to insert an item because your last location is also full, so that is your overflow condition. Okay, I think this is clear. Then dear students, in step 2 you can see if the queue is not full. Okay, in the first step we can check the queue is full. There is no space for new item, so we can write the queue is overflow. But suppose the second case, when the queue is not full, then what happen? So dear students, suppose in first case there is no item in the queue, our total queue is empty. So in that case, front is -1 and rear is -1 because our address location start from 0. Okay, here you can see our address location start from 0. Okay, so at second step our front and rear end is equal to -1, which means that our queue is empty. There is no element inside the queue. Okay, so in case of first queue you can see an arrow where the front and rear end point to -1, which means that our queue is empty. Second thing, if our queue is empty, then we are moving to our first location. Okay, that's why we are writing here front and rear is equal to 0. So in second queue you can see whenever you want to add an element and if the queue is empty, so that element is stored at first location. So here in second queue the front and rear end point to 0th location. Okay, then in the else you can see the rear is equal to rear plus 1. So here you can see the rear is equal to rear plus 1, which means that, dear students, suppose you are adding one element, so that element is stored at 0th location. Now that element that you stored at 0 location, that is 10, but if you want to add 20 again, so in that case you can find out that what is our next location. So dear students, after A0 our next location is A1. So here you can see our rear end point to A1, and our front end remain at previous location. So dear students, what you have to remember in case of insert operation, always your rear pointer can proceed to next location. And what happen in case of deletion operation, always your front end or front pointer move to next location. So here you can see whenever we are adding 20, our rear pointer move to A1. Suppose if we have to add 30, then our rear pointer move to A2 and our front pointer remain in previous location. So this is the description of our insertion operation in case of Q. So these concepts, okay, so these are our insertion operation concept in Q. Now we are covering deletion operation. So dear students, as I can tell you, in case of deletion operation, you have to set your focus on front pointer. Okay, so what happened in case of deletion operation, in our first condition you can check if our queue is empty or not. Okay, so dear students, suppose our queue is empty, that means that there is no element inside the queue. Okay, so if the queue is empty and we are trying to delete an element, that can produce underflow condition. So what is our first step? In case of first step, we are checking whether our queue is empty or not. If the queue is empty, then we are trying to delete an element, it will produce underflow condition. Second thing that you can see, so dear students, if the queue is not empty, okay, second thing, if the queue is not empty, so this means that you can delete an element from the queue. So in this image you can see, so whatever I am telling you, in first queue our front pointer is at 0th location and our rear pointer is at first location. I think this is clear. Now I want to delete the element 10. Okay, so in second queue you can see whenever we are performing deletion operation, we have to set our focus on front pointer. So here you can see our front pointer move to next location and our rear pointer stay at previous location. So in second queue you can see whenever we are deleting an element from queue, so our 0th location is empty, so our front pointer will move to first location. Okay, so what we can learn in case of insert and delete operation in queue? In case of insert operation, our focus is on rear pointer, but in case of deletion operation, our focus is on front pointer. Now we are covering types of queue. So dear students, there are various types of queue, just like circular queue, priority queue, double-ended queue and multiple queue. Now we are covering circular queue. So what is a circular queue? Okay, so dear students, basically a circular queue is similar to a linear queue, as it is also based on FIFO principle. Okay, so whatever our queue, that is based on FIFO principle, except the last position is connected to the first position in a circular queue, that form a circle. So dear students, what happens in circular queue? The last position is connected to the first position in a circular queue and that form a circle. So here you can see, in case of circular queue we have a ring buffer. Okay, what happened? Our last location, that is Q7, is connected to Q0. Our first location is here Q0 and our last location is Q7. Here our last location, that is Q7, is connected to Q0 and form a circle. That's why this Q is known as circular Q. I think this is clear to you. What happened in circular Q? The last position is connected to the first position in a circular fashion. That's why it form a circle. Okay, so I think this is clear. So dear students, there is a question in your mind, sir, why we are using circular Q? So dear students, in case of linear Q, you can see there is wastage of memory. Why there is wastage of memory? You can see whenever we are deleting an element in this Q, we have total size of Q, that is 5. Okay, so whenever we are starting to delete an element, suppose I am deleting an element from second location, 30 is deleted, front pointer moved to third location. Then suppose I am deleting an element from third location, then front pointer moved to fourth location. Okay, now our front and rear pointer is at fourth location, and if I want to insert an element into the Q, it is not possible. Why it is not possible? Because at our last position we have an element. Okay, always it can produce overflow condition, but we can see our previous locations are empty. Okay, due to this wastage of memory, we are using the concept of circular Q, where the last position is connected to the first position. Okay, so here you can see what is the definition of circular Q: a Q where the last node is connected to the first node to make a circle. Now here this is our image which is regarding to the circular Q. Dear students, this is our insertion operation for circular Q. Now what happened in circular Q? Again similar concept. First of all, we have to check whether it is overflow or not. So whenever your front is equal to 0 and your rear is equal to max minus 1, which means that you can see whenever your front is at initial location, starting location, and your rear is at final location, so you can see that there is no space for new element. So always whenever you are trying to insert an element, it will produce overflow condition. Why overflow? Because the Q is full. Now second, here you can see after checking overflow, okay, suppose there is no overflow and we want to insert an element. So first of all, we have to check whether there is an element in the Q or not. If there is no element, so you can see the front and rear is equal to minus 1 because the Q is empty. In that case, you are placing the element at first location, and for first location you can see our front and rear address are same, so that is 0. Okay, in case of circular Q, whenever you want to insert an element and there is no element in the Q, then you can insert an element at the first location. So here our first location is Q0, which point to front and rear end. Okay, I think this is clear. Now second thing, suppose our rear is equal to max minus 1 but our front is not equal to 0. What is second part? Our rear is at last location but our front is not at first location. In that case, we are making our rear pointer at 0th position. How? You can see in this image. So dear students, here you can see our rear pointer is at last location, okay, but our front pointer is at first position. So here you can see our 0th location is free, okay, and also you can know in case of circular Q we have the possibility to connect our last node to the first node. So whenever you want to insert a new element, so rear pointer will point to initial location, that is Q naught. Okay. Next thing, so dear students, also there is another condition which is set rear is equal to rear plus 1. Okay, so in this image you can learn this concept. Okay, so again, what is rear? Why rear is equal to rear plus 1? Suppose this is our circular queue and initially our front and rear end is at 0th location. Here you can see initially our front and rear end is at 0th location. Now if you want to add new element, in that case you have to move to first location. So as I can tell you, in insertion operation always our rear pointer will move to next part. So our front pointer remain at 0th location and our rear pointer will move to first location. So here you can see, here we are inserting second element, that is 10, and that element is stored at first location. So dear students, this is our insert operation in circular queue. Now we are covering deletion operation in circular queue. So in case of deletion, as I can tell you, first of all you have to check whether the queue is underflow or not. So what is underflow? Suppose there is no element inside the queue and you are always trying to delete an element from the queue. So always it will give underflow condition. Then suppose there is no underflow condition. We are moving to step 3, where if the front is equal to rear, then front is equal to rear is equal to minus 1. What is this? Now in this image you can see, for underflow our front and rear end will point to minus 1. Okay. Second thing, when our front and rear is equal to 0. So dear students, here you can see in this condition, suppose our queue contain one element and that element is 5. This is clear, and that 5 is stored at 0th location. Now you want to perform delete operation. So whenever you are performing delete operation, our element is removed from 0th location and our front and rear pointer will point to minus 1. That's why we are writing here front is equal to rear is equal to minus 1. Why we are writing this? Because we are deleting the only one element from the queue which is stored inside this circular queue. Next thing that we cover, if front is equal to max minus 1, set front is equal to 0. So in this image you can see if front is equal to max minus 1. So our front is at 7th location, that is the last location of circular queue. In that case, what happen? You have to set your front at 0th. Okay, so what is that? Whatever you are performing, you have to follow the conditions. Okay, and in case of deletion, you have to set your main focus is at front point. Okay, similarly here we have our next condition, which is such like that, where the front is equal to front plus 1. What is this? Here you can see our front is at Q1 location. Clear? And you want to delete 15. In that case, you have to move from next location. So here, whenever you are deleting 15, it can move to next location. Okay? So you can see our front is equal to front plus 1. So here your pointer will move to 4th location. Okay. So these are our circular queue operation. Now we are covering another type of queue, and that type is priority queue. So dear students, what is an priority queue? A priority queue is an abstract data type. Okay, what is it is? It is an abstract data type that behave similarly to the normal queue. Okay, this queue is similar to the normal queue except that each element has some priority. Okay, so what happen in priority queue? Each element has some priority and the elements are processed on the basis of their priority. So what happen in case of priority queue? Each element is assigned a priority and on the basis of priority the order in which the elements will be processed. Okay, what is the priority of specific element? According to that priority we can process the element in the priority queue. Okay, so dear students, in case of priority queue, two things are always remember. An element with higher priority will processed before an element with the lower priority. I think this is clear. What happen in priority queue? An element with higher priority will processed before an element with a lower priority. Second thing, whenever we have two elements that have same priority, so in that case we are using first come first serve basis. Okay, so whenever we are trying to access the elements, we are using first come first serve priority. Okay, so this is our priority queue. What happen in priority queue? A priority is assigned to each element. Okay, the elements are processed on the basis of priority. There are two rules. The element with higher priority is processed first. Second thing, if two elements have same priority, then these elements are accessed in first come first serve basis. Okay, then dear students, we have two types of priority queue. Our first type is ascending priority queue and our second type is descending priority queue. So what is ascending priority queue? In case of ascending priority queue, the elements can be inserted into any order, but only the smallest element can be removed. So dear students, in case of ascending priority queue, you have to remember you can insert an element in any order randomly, but whenever you are performing the deletion operation, you have to remember you have to remove smallest element first. Okay, second thing we have, that is descending priority queue. In case of descending priority queue, the element are inserting in any order, what the largest element can be removed first. So there is two basic difference between ascending or descending order. The difference is insertion is randomly, but in case of ascending, first of all smallest element is removed, but in case of descending, first of all the largest element can be removed. I think this is clear. Then again dear students, we have array representation of priority queue where we are performing insertion operation. So whenever you are performing insertion operation, you have to remember few things. The first thing is that while inserting elements in priority queue, we will add it at the appropriate position depend upon its priority. So what you have to remember, whenever you are inserting an element in priority queue, you can add it at its appropriate position depend on its priority. Second thing, It is inserted in such a way that the elements are always ordered either in ascending or descending sequence. So dear students, here we have insertion operation for priority queue. In this operation, the elements are inserted at their appropriate position based on their priority. Second thing, these all elements are inserted on the basis of ascending or descending sequence. Okay, so here you can see this is our array representation of priority queue. Okay, now we have our deletion operation. So dear students, in case of deletion operation of priority queue, you can always remember the elements are removed at the front. Whenever you are performing deletion, you have to remove the element at the front. So this is our array representation of priority queue. So this is our today's session where we are learning regarding the concept of queue. What is queue data structure? What are various operations of queue data structure? What are various types of queues, just like circular queue and priority queue? Okay, so thank you for joining our today session.